Greetings, folks. Today we are going to go through running some t-tests in SPSS, and we are going to be running both kinds of t-tests. There's the independent samples t-test, and we are also going to run the dependent or paired samples t-test. And these two can be a little confusing, so what we're going to do is kind of look at the data first to discover what we're dealing with and why we're running the two different types of tests and which one you're running for what reason. This is a tiny little sample population of some 8th graders that took a math test, and then they had a lecture about it, and a week later they took a second math test. So let's look at our data. So I come down here, I've got the data view and the variable view. I'm in the variable view right now, down here in the bottom corner. And this variable view is showing me what my variables are. My first variable is the scores from test 1. My second variable has the scores from test 2. And my third variable is the gender of the students. And we can see that the variable has been labeled 1 is female and 2 are male. So I'm going to flip again down here. I'm just going to click on data view, and here is my data. So this first participant took the test 1 and scored a 7.17, took test 2 a week later after the lecture and scored a 9.99, and the gender is 1. Now if I forgot what the gender is, if I forget which one's 1 and which one's 2, I can simply go up here to this little box that has the pink 1 and the pink A, and that's allowing me to choose which one I want to view. I can view the 1s and the 2s, or I can view the female and male. And I love that button. I always know then when I've captured and what I'm doing, and when I've captured all the data. So the two different types of t-tests that we can run. If we run a paired samples t-test, also known as a dependent t-test, every participant is in both conditions. So if I wanted to compare test 1, I can see that this first subject took test 1, and if I wanted to compare that to test 2 scores to see if overall the entire class did better, participant 1 also took test 2. So participant 1 is actually in the condition of test 1 and the condition of test 2. This makes it a paired or a dependent samples t-test. And how it works is SPSS is actually going to take an average of all of the scores, and it's going to compare the average score from test 1 to the average or mean score from test 2. And it's going to tell us then whether those two scores are significantly different from each other or if they're just slightly different due to chance. If I want to run an independent samples t-test, that is when the participants are not in both categories. So let's say I wanted to know if females did better or worse than males significantly for test 1. I want to just know, just looking at test 1, did the females or the males do significantly different from each other? So if you are a female, you cannot also be a male. If anyone wants to argue that point, that's a completely different class. That would be what, sociology, I guess. Anyway, so let's get started and let's run a independent samples t-test first. So let's see if the males and the females are different from each other for test 1. I'm going to go up here to Analyze. I'm going to click on Analyze, and I'm going to come down to Compare Means. And this is what we're doing. We're literally seeing if the averages in the group are different from the averages in the other group. And I'm going to run an independent samples t-test. I'm going to click on this. I want to know if test 1, for test 1, are my males and females different from each other? So this is my grouping variable, and it's gender, but I need to define what the groups are. It's not always gender. Sometimes it's different colors, different ages, whatever however they're grouped is how we're going to define it. So I'm going to call group 1. I can either say 1 or female, and I'm going to call group 2 2. And I am telling SPSS how I want these to be grouped. I'm going to hit continue. I'm going to look at my options box, and I'm going to see that it's already picked a standard default, and I'm completely fine with that. We're going to leave that alone. But I always want to check my options box when I'm in SPSS, because oftentimes in that options box will allow me to pick descriptive statistics, or whether or what measure of central tendency I want, whether I'm looking for the mean, median, mode. So don't be afraid of these extra boxes. I'm going to hit OK, and voila, out comes my output. Love it. So what are these boxes? What do they mean, and why do they keep just popping up in my face? Okay, again, we did an independent samples t-test. We're wondering if the males are different than the females. And I can see right here that I had 15 females, that their average test score for test 1, here it shows test 1, their average test score was 8.39 with a standard deviation of 1.8. My males, I had 14 in the group with an average mean score of 8.28 and a standard deviation of 1.87. So are those statistically significantly different from each other? First thing I'm going to want to do is I'm going to want to look at my Levine's test for equality of variances. What Levine's test is doing for us is it is telling us whether or not we have broken the assumptions when we're running our statistical analysis. If Levine's test is below 0.05, so that's the significance level for the Levine's test. You can see here there's a line right here, a vertical line right here. These two scores, the F and the significance scores, are part of Levine's. If the significance score is below 0.05, that means it is significant. That means we have broken the assumptions, and we want to look at the information on the second line that says we're not going to assume equal variances. In this case, this number 0.72 is actually well above 0.05. We did not break any assumptions, so we are going to assume that they had equal variances in the two different groups. So I'm going to get my information from the top line. My t-score is 0.15 with a degrees of freedom of 27, and my significance is 0.881. Now I'm going to look at the significance score, 0.88. That's my p-value. And I'm going to see that my p-value is well above 0.05, which means these two scores are not significantly different from each other. And that is how that works. So let's see real quick. I am going to write it up. I am going to, when I'm writing this, let me get my I have one of those great new mouse pads that doesn't always agree with me, but yeah, if that's the worst thing that happened tonight, that's okay. Some of the worst parts of learning statistics, statistical analysis, is also learning how to write them up properly. I'm going to be writing everything in APA style. The first thing I want to do is discuss which test I ran. So I'm just going to say an independent samples t-test was run with, and now let's talk about our variables. Gender as our independent variable. That is hold on 1 second. And I had to think. I had to regroup because I'm doing 2 different tests tonight. So my brain, of course, just blocks when I don't want it to. With gender as our independent variable and test 1 scores as our dependent variable. T-test results indicated that, and now I want to put my groups so I can, this is where I'm going to add my descriptive statistics, that females, and I need to put the number of females. So some people don't know whether we want to use a big N or a little n, or an uppercase N or a lowercase n. And because the entire population has 29, the sample population has 29 subjects, but females are only 15, they are a portion of the sample, I'm going to use a little n. I'm going to have a space, an equals, a space, and females are 15, comma, the mean, space, equals space, 8.39, whoops, sorry about that, didn't have my numbers lock on, 8.39, and the standard deviation, space equals space, is 1.80, 1.80. I'm going to write all that, and I'm going to go back and I'm going to make sure that my abbreviations are italicized. And they were not significantly different from the males. And the males, again, the information is right here. So I'm going to do my lowercase n. To 9. I can round. Follow the rounding rules. If it's above 5, you want to round up. 1.87. There really is not too much of a quicker way to do this, but sometimes you can copy and paste and change the numbers if it's a little bit easier on you. And at this point, I now want to put my t-test. So I'm going to do my t, and immediately with no space, I want my degrees of freedom. Which is 27. Space, equal, space. I'm going to put my actual t-score, which I'm going to find right here, this 0.151. And we do not do a leading 0 on our t-score or our p-value. they are numbers that should not be over 1. When the number does not go over 1, when it's a number that exists between 0 and 1, you do not use a leading 0. And then I'm going to put my p-value, and my p-value is the significance under the t-test. It's under the t-test. It is not the significance for Levine's. It's the significance right here on the top row under the t-test. And it is 0.881. 0.881. And I will make sure that my p is italicized as well as my t. And I'm actually, you know what, why don't I make this a little bit bigger font so everybody can see it? I should have started out that way. I apologize. And I'm going to give you a second and just leave this up in case we want to use this for future records. This is a great way to say it. We've addressed what test we've run. We've discussed which the independent and dependent variables are. We've also said whether or not it is significant, and then we've shown our t-test for proof, or the numbers that show that it is not significant. That is not so bad. Part of the headache comes from bringing in our boxes. So when I bring over my boxes, my output boxes, I always leave a little bit extra space, because if you get them up right next to each other, you're not going to be able to move them very well. And the dreaded t-test box. And again, I'm going to grab an extra space here. And I'm going to put that right in there. Now, this is why I said the dreaded t-test box. The t-test box is extremely long. It's so long that we don't even see the end of it over here. There's a couple of tricks. If you go down below in Word, you make this a little bit smaller. Eventually, this little box will appear out here, floating in Never Never Land, and you can squish it all in. So it will fit within the margins. I'm going to go back to regular size. And it's all squished. I can see my numbers are kind of funky right here. Some of my words are real funky. So what I like to do is play with it a little bit so it'll be a little bit nicer presentation. And you can move these lines one by one. Let's do Levine's test for variances. That should give us a little more room. And then I take the words difference and I shorten these. I change confidence interval to just CI. That gives us a little bit nicer. I did not think that running statistics or quantitative analysis would be so much about formatting. That was a kind of a surprise to me, as I'm sure some of you are learning. But presentation does matter. And there we go. Oh. Well, that one hurt a little bit. Alrighty, so now we have addressed our independent samples t-test. And we see that there is no difference between gender for test 1. We can, if we're interested, go right in and we can say, now I want to know about test 2. And I want to compare the means. Again, does gender make a difference for test 2? I'm going to run the same test. And I see here that what I just ran is already sitting there. So I just have to take test 1, put it over, take test 2, bring that into my test variable box, click OK, and boom, I have my answers. And when I look for test 2, I look at my Levine's test. I see it's above 0.05, so I'm going to read the top line. And again, the t-test itself is also above 0.05. It is not significant. So gender does not have an impact on math test scores. Now, if I would like to run a paired samples t-test, that's when I want to see, is there a difference between test 1 and test 2? Is there a difference? So I'm going to go into Analyze. I'm going to go into Compare Means, and I'm going to run a paired samples t-test. This box looks quite different, and what it's telling me is for each pair, what is one variable, what is the second variable. So test 1 is one variable, and test 2 is one variable. And you can see it opens up right here. It opens up. I can run 3 or 4 paired tests at the same time. We're not going to do that. We're just going to run the one tonight, but I can. I look at my options box. That's not one that has any information for me. So I hit OK, and voila, I am done. Now, as I look at this, as I look at my output boxes, I see there's 3 different boxes. I've got my paired samples t-test. So test 1, the average score for test 1 was 8.34 and 29. That was all 29 subjects took the test. The average with a standard deviation of 1.8. The average test score for test 2 is 10.17. I was all 29 subjects, and the standard deviation was 2.6. So I want to know if they're significantly different from each other. I look down to the third output box, and I see that my significance, my p-value, is 0.000. So yes, these 2 scores, test 1 and test 2, the means are significantly different. So when it comes to writing up test 1 and test 2, I'm going to show you a little trick that I do. We can just kind of copy and paste some of this if we'd like. You have to be sure and change it all. But sometimes you can copy and paste it. But you know what? Maybe we should just start over and that'll be more clear. So let's come down to the end here. Alrighty. And a paired samples t-test was run with test 1 as the independent variable, and test 2, this would probably be better if I said scores. Test 1 scores as the independent variable, and test 2 scores as the dependent variable. Now at this point I've separated out test 1 and test 2 scores. I could very easily see, I tried to do something easy. And my mouse is being a brat. You have to be honest, though. This is pretty exciting stuff we're doing, right? Just kidding. So, test 1 scores. The mean is 8.34 with a standard deviation of 1.80. And test 2 scores had a mean of 10.17 with the mean, with the standard deviation, with a standard deviation of 2.63. So now I've got my descriptives in. I've also said which type of test I've run. I've discussed what the variables are, which one was the independent, which one was the dependent. Results of the paired samples t-test showed, I don't like the word showed. I don't know why. That test 2 was significantly. And right here you can put higher, lower, worse, better, more green, whatever it is that you're looking at. Test 2 was significantly higher. That test 2 had significantly higher scores than test 1. Oops. And then you should probably put your t-test, or it just doesn't really help much. Doesn't show that you ran it real well. Now the first thing I see when I'm looking at this output box, these are the differences. So no one's average was a negative 1.8. That's actually the difference. If you take 10.16 or if you take 8.34 and subtract 10.16, the difference is 1.82 or negative 1.82. So these are the differences. We don't want to look at this to get our information for either our mean or our standard deviation. But I do want to get my t-score from over here, my t-statistic, and my degrees of freedom are 28. My actual t-score is, there's a negative there, but you can drop that. And my p-value, now when SPSS says 0.00, this is never what we write. The only time we ever change our p-value is when it is actually 0.00. And that's because if we can click on it, there we go. There actually is a number there, but for some reason SPSS just cuts it off at the 3 digits. So the number does not equal 0, but we do know that it is less than 0.001. So we are confident to a 99.9% if we report that it is less than 0.001. And that is the only time you would change the p-value. As you'll notice on the test above, we put the actual p-value. But when it is 0, 0, 0, we report it as less than 0.001. We're going to make our p and our t italicized. And that one is significant, so we would reject the null hypothesis. But this is how you run a t-test. And for the paired samples t-test, when we look at our output box, you'll notice that I took information from this box and I took information from this box. I did not take information from this box. It's best to get in the habit of only copying and pasting the boxes that you have used. Do not copy and paste every box that you see in your output, because different boxes are going to be what you're reporting on, and the rest just becomes a confusing eyesore for the reader. So you need to pay attention. Where did I get my information? Whoops. Double click there. There we go. The two programs are not the most compatible. They actually remind me of maybe an ex-husband and an ex-wife. I don't know. They tend to be rather finicky with each other. There's my little white box. I'm going to bring that over, and I can see that I have some. Can I do it? Oh, it's this one. You just got to play with it for a minute, and it will look much better. If you put a little time into your charts and your tables, they will look so much nicer. It did take me about, I don't know, 10 years of doing this to get this comfortable with it. It is much more annoying and frustrating than I admit, trying to make these tables look nice. But there we have it. And that, ladies and gentlemen, is how we run our paired samples t-test and our independent samples t-test. Enjoy!